Welcome to the Deep Dive. Today, we are exploring a really fascinating stack of material from Chronicle Craft Technologies.
Yeah, it's detailing a pretty major shift in how we interact with complex computer systems.
Right. And our mission for you today is to unpack a project they're calling VORTEX
Hmm.
and, to see how they're trying to solve a problem that honestly plagues almost every highly technical field.
Exactly. And to get started, just consider for a moment how Hollywood portrays cybersecurity.
Oh, yeah. The classic movie hacker.
Right. If you watch a movie, you always picture like a hacker in a dark room wearing a hoodie, just furiously typing these lines of bright green code, right?
Yeah. And they always break into a mainframe in like 30 seconds flat.
Exactly. It always looks incredibly kinetic. It looks effortless, but the day-to-day reality of that job is, well, it's drastically less cinematic.
I can imagine. It's a lot more staring at screens, right?
Oh, totally. A massive portion of a security operator's time is actually spent just glaring at a terminal screen. They're reading dry technical documentation and trying to figure out why an entire network scan failed.
Just because of a typo or something?
Basically, yeah.
Yeah.
Usually just because they misplaced a single hyphen in this massive string of text.
Wow. So the barrier to entry for utilizing these incredibly powerful security tools isn't usually some dramatic battle against a sentient firewall.
Not at all. Often the biggest hurdle is simply the incredibly dense, complex command syntax you're just forced to memorize to get the tools to function properly.
And that is exactly the friction point Chronicle Craft Technologies is targeting with VORTEX. VORTEX stands for Voice Operated Recon and Tactical Exploitation Executor.
It's quite a mouthful, but it's incredibly accurate to what it does.
Yeah, so to give you a guiding analogy for what we're exploring today, I want you to imagine having a consumer smart home assistant.
Like the ones we all have sitting on our kitchen counters.
Right, exactly. But instead of sitting on your couch and saying, turn on the living room lights, you're sitting at a security terminal and saying, run a comprehensive vulnerability scan on this entire corporate network.
It's wild to think about. Vortex basically bridges the gap between complex computational power and, well, simple natural human communication.
But there's a critical piece of nuance to add to that analogy right away, isn't there?
Oh, absolutely. And this is what makes Vortex fundamentally different from a consumer gadget. This is built specifically for authorized security testing, and educational environments.
So not for rogue actors trying to break into places they shouldn't be.
Exactly. The core focus here is translating human intent directly into real, tangible, offensive security operations, but doing it in a way that absolutely never sacrifices operational control or data safety.
Let's dig into that idea of translating intent. Because if you want to understand what Vortex is actually replacing in a security operator's life, you really have to understand the true cost of context switching.
Yeah, context switching is a massive drain. Cybersecurity tools have evolved to become incredibly powerful, but that power brings, like, an avalanche of complexity.
Right. So when a security operator is hunting for a vulnerability in a system, their brain is operating in this state of high-level logical flow.
Exactly. They're thinking about architecture, analyzing potential weaknesses, and, strategizing their next move.
But the moment they have to stop and manually type out a command, they are forced to break that flow.
They have to suddenly shift their brain from high-level strategy down to this menial syntax checking.
Like they have to wonder, does this specific flag require a lowercase s or an uppercase s?
Yeah. Or did I put the IP address in the right order? That cognitive load is massive, and forcing a human to act as a syntax checker basically shatters their focus.
So with Vortex, the goal is to remove that friction entirely. An operator can communicate naturally. You can type a plain English command, or you can literally speak it out loud into a microphone.
Right. Vortex captures your input locally, figures out what you're trying to achieve, translates that into the appropriate parameters for a tool called Nmap, and then executes the scan.
And Nmap is really the foundational tool being utilized under the hood here.
It is, and for those who might not spend their days mapping networks, just think of Nmap as a digital sonar.
A digital sonar. Okay, I like that.
You use it to ping a building's infrastructure to see exactly which doors and windows are open, which ones are locked, and what kind of locks are on them.
But the controls for that digital sonar look like a chaotic math equation.
Oh, it's ridiculous. A typical command to do a thorough scan might look something like typing out nmap dash small s capital S dash small p dash dash capital T 4 dash capital A dash small v followed by an IP address.
Which sounds completely absurd when spoken out loud.
It really does.
But, I have to challenge the premise of Vortex just a bit here.
Okay, go for it.
If I speak into a microphone and a machine just turns my words into that string of Nmap commands, isn't this just a glorified voice-to-text dictation tool?
That's a fair question.
Like, how is this fundamentally different from just dictating a text message on my smartphone?
Right, so dictation is a literal translation of audio to text. If you dictate a text message, your phone is simply spelling out the exact words you vocalize.
It isn't trying to understand the meaning behind them.
Exactly. But Vortex is performing something fundamentally different called intent parsing.
Intent parsing.
Yeah, you absolutely do not have to speak those exact flags and syntax out loud. You don't say execute nmap dash small s capital S.
So what do you say?
You simply tell the machine your overarching goal. You might just say, find all the open ports on the accounting department's server.
Wow. And the machine just understands the objective and builds the complex command string on your behalf.
Exactly. The user expresses the intent, and the machine handles the syntax.
That's incredible.
It is. It's entirely removing the command line dependency for everyday operations. It allows the operator to stay in that high-level strategic flow state without ever having to remember, like, a specific combination of letters and dashes.
Okay, so if Vortex is stripping away the need for the human to type the syntax, something still has to physically build and execute that command.
Right.
How is the machine actually bridging that gap between human speech and a highly technical network scan?
It essentially mimics human biology. The architecture is broken down into 4 core components, starting with what they call the ear.
The ear. Okay. So this is the local speech recognition system.
Yes. This is the part of the architecture that physically listens to the spoken audio and transcribes it into text so the system can actually process it.
And what's powering that?
This specific component is powered by a model called Whisper.
Oh, Whisper.
Yeah, it's an artificial intelligence model trained specifically to understand human speech patterns incredibly well.
So it can handle different voices and environments?
Exactly. It's robust enough to handle thick accents, background noise, and highly specific technical jargon without stumbling.
And most importantly, in this architecture, it is configured to run entirely on the user's own hardware.
Entirely local, yes.
Okay, so once the ear hears the command, the text gets passed along to the brain.
Right, the brain.
And here is where the engineering gets genuinely fascinating to me.
Mm-hmm.
Because the brain isn't just one monolithic artificial intelligence.
No, not at all. It's a hybrid intelligence layer.
Right. It actually splits the processing duties between 2 very different systems.
Yeah.
Deterministic command matching and a local large language model for deeper interpretation.
That hybrid approach is, frankly, arguably the most crucial engineering choice in the entire Vortex architecture.
Really? Why is that?
Because it perfectly balances speed and reliability with flexibility.
You know, I was thinking about this split brain in terms of human reflexes versus deep thought.
Oh, that's a great way to put it.
Like, if I accidentally touch a hot stove, my nervous system does not send a signal all the way up to my brain, so I can ponder the philosophical implications of heat transfer.
Right, your hand is already gone.
Exactly. My reflex just pulls my hand back immediately.
Yeah.
It's deterministic. It's an automatic, pre-programmed response to a specific trigger.
Yes.
But if someone asks me to solve an algebra problem, a reflex won't help me. I have to route that information to my deep thinking brain to actively process it and figure it out.
That is a perfect analogy. The deterministic matching side of Vortex acts as that reflex. It functions like a strict flowchart or, a lookup table.
Okay.
If you give it a very standard, highly specific command, it maps that input directly to a known output without any creative processing at all.
But wait, why do we even need the reflex at all? I mean, artificial intelligence has gotten so advanced recently. Why not just route absolutely everything through the language model and let the AI handle the entire process?
Because language models, by their very nature, are probabilistic engines.
Meaning they guess.
Exactly. They are designed to predict the next most likely word in a sequence, which, makes them incredibly creative and flexible. But that creativity comes with a massive downside.
They hallucinate.
Yes,
Yeah.
They hallucinate. They invent things. They sometimes combine parameters in ways that don't actually exist.
Which is bad.
Very bad. In the realm of cybersecurity, precision isn't just a nice-to-have feature. It is an absolute operational requirement.
Because you absolutely do not want your security tool getting creative when it's actively scanning a live, delicate corporate network.
No, you do not. A hallucinated command could cause a system crash or trigger a massive security alarm.
So the deterministic matching acts as a safety net.
Yes. It ensures that standard, known commands execute perfectly, instantly, and exactly the same way every single time.
And absolute reliability.
Right, and then the local language model is only called upon to step in when the operator's natural language is messy or complex, or requires that deeper interpretation that a simple reflex flowchart cannot handle.
So the system intelligently routes the request to whichever side of the brain is best suited for the task.
Exactly, it's very smart routing.
Okay, so we have the ear listening, and we have the hybrid brain translating the intent into a safe, reliable command. Next, we move to the hands.
The hands, this is the actual execution phase.
Right. This is the real Nmap software running directly on the local machine, performing the active network scan.
Yeah, it's the physical manifestation of the intent. The hands take the perfect syntax generated by the brain and literally throw it against the target network to see what bounces back.
And finally, we have the mouth.
The mouth.
Once the scan is complete, VORTEX has to deliver the results back to the operator. And it does this through a clean web interface, but also through offline text-to-speech.
Right. It literally speaks the results of the scan back to you out loud.
Which completes the human-computer communication loop. You speak to the machine understands your intent, it acts upon the environment, and then it verbally reports its findings back to you.
Exactly. And that allows you to keep your eyes on whatever other screens or data you might be analyzing.
It's so seamless. But if you've been paying close attention to this breakdown, you might have noticed a recurring theme here.
A very intentional theme.
Local speech recognition, a local language model, execution running directly on the local machine, offline text-to-speech.
Every single component is intentionally isolated.
And that brings us to the overarching philosophy driving the entire VORTEX project, which is absolute privacy and control.
Because the current state of modern technology is, let's face it, almost entirely tethered to the cloud.
It really is.
When you use a digital assistant or a smart speaker or even most modern enterprise software, your data is constantly being packaged up, sent over the internet to some massive data center, processed by a third party, and then sent back to you.
But VORTEX is engineered to be entirely offline.
Entirely.
Chronicle Craft Technologies designed this system with zero mandatory cloud infrastructure. There are no required third-party API subscriptions to pay for.
Which is huge.
Yeah, and there is no telemetry quietly tracking how you use the tool. And most importantly, there is absolutely zero dependency on sending sensitive security data to an external service.
And finding an AI-assisted tool with that level of isolation is incredibly rare right now. The industry standard is to rely on external servers because running artificial intelligence locally requires significant computational power.
But the creators of VORTEX recognize that in the security sector, sending data outward is basically a non-starter.
It's a deal breaker.
So to really visualize why this matters so much, let's look at the mechanics of data leaks.
Okay.
Doing a penetration test on a highly secure network while connected to a cloud-based AI API, it's like hiring a professional locksmith to test the security of your home.
Right.
But the locksmith insists on standing in your front yard and shouting your alarm codes to his boss over a megaphone.
That is exactly what it's like. You are actively broadcasting the exact vulnerabilities you are trying to secure. And taking that exact same vulnerability and scaling it up to a real-world scenario like a hospital network or a financial institution or a critical infrastructure grid, it makes the danger so incredibly clear.
Yeah, you are actively finding and documenting the weakest points of a network, sending that highly sensitive penetration testing data, or even just the IP addresses of the targets you are analyzing, over the open internet to a third-party leverage model is just a massive security risk in itself.
Because you're trusting an outside corporation to hold the blueprints to the open windows of a highly secure building.
Exactly. It's the very definition of poor operational security.
But VORTEX bypasses that entire risk profile by keeping all of its intelligence locally housed on the operator's machine.
The guiding ethos of the project is summarized basically as your environment, your intelligence, your operation.
I love that.
Every verbal command you give, every network target you scan, every result that bounces back, and your entire session history remains entirely within your own closed environment. The data never leaves the room.
Which is just a major technical achievement. They are delivering the convenience of a modern, cloud-based smart assistant, but they're confining it entirely within a secure, air-gapped bubble.
Exactly.
So we have established that the architecture is powerful, and the philosophy is built around absolute privacy. But what does this actually look like when you sit down in the chair to use it?
You mean practically speaking?
Yeah. How does Vortex physically change the workflow of a security operator on, say, a Tuesday afternoon?
Well, the operational workflow becomes incredibly streamlined.
Yeah.
The process is basically reduced to speak, execute, observe, review, report.
Wow.
The complexity of managing the tools just sort of fades into the background, leaving only the tactical operation.
And one of the most impactful features for the day-to-day workflow is the built-in session database.
Oh, the database is a lifesaver.
Because as you were speaking commands and running scans, Vortex is quietly recording every single operation locally.
Yes, you can go back and review previous sessions. You can filter your results to find specific vulnerabilities.
And you can generate complete formatted HTML reports with a single click.
And anyone who has worked in technical testing knows that documentation is often half the job.
Right. You don't just find a vulnerability, you have to prove how you found it.
Exactly. What the response was, when it happened. Usually, an operator has to manually copy and paste terminal outputs into a document, format the text, build tables of open ports, write up summaries. It's tedious.
But automating the generation of an HTML report, a clean, readable web document containing all your timestamps and structured data, while keeping that data totally secure, is a massive efficiency boost.
It truly gives hours of time back to the operator.
Now, currently, Vortex is described as a feature-complete proof of concept.
Right, it's a starting point.
The tool actively works, it utilizes the local intelligence, and it successfully runs Nmap scans via voice. But the developers are really looking at the horizon.
They have big plans.
The future roadmap for the project includes expanding the capabilities of that local intelligence and improving how the system understands complex voice commands.
Yep.
And crucially, extending the security tooling beyond just Nmap. They want to include a whole suite of offensive and defensive capabilities.
And they are also focusing on making the entire package easier to deploy at scale across different environments.
They are essentially laying the groundwork for an entire ecosystem of voice-operated offline security tools. Vortex is really just the first iteration of a much larger shift in how we interface with diagnostic software.
But, this brings up a pretty fascinating philosophical question about the future of the industry.
Okay.
If you completely remove the friction of the command line, right? If you extract away the syntax and make these powerful tools as accessible as talking to a smart speaker, do we risk making security operators lazy?
That's a debate that happens a lot.
Like if a new generation of professionals grows up just telling a machine to find the open ports, do they lose the fundamental granular understanding of how the tools actually work beneath the surface?
The fear of abstraction making us lose fundamental skills comes up every single time technology evolves. We worried about it with calculators. We worry about it with autopilot.
That's true.
However, an entirely different conclusion can be drawn from the trajectory of this project. The future of cybersecurity isn't going to be defined solely by who can build tools with the most raw computational power.
It's not.
No. It is going to be defined by making that power accessible, private, and seamlessly controllable.
So the goal isn't to coddle the operator.
Not at all. The goal is to elevate their perspective. Removing the friction of syntax allows the human operator to focus their energy entirely on tactical strategy and analysis.
Which is where the real value is anyway.
Exactly. You want your highest paid, most experienced experts looking at the bigger picture. You want them analyzing the architecture of a network, spotting logical flaws, and anticipating how an adversary might move through a system.
So you are not making them lazy by giving them a voice assistant. You are freeing up their cognitive resources.
Yes, you are allowing them to do the actual high-level intellectual security work rather than forcing them to act as human syntax checkers.
That makes a lot of sense. So when you step back and look at the whole picture, whether you are a seasoned tech veteran who has spent years staring at a blinking terminal cursor, or you are just someone fascinated by how human-computer interaction is evolving in real time, Vortex represents a major paradigm shift.
It really does.
We're slowly moving away from a world where humans have to bend over backwards to learn the rigid, unforgiving language of the machine.
And we're finally entering a world where the machine is learning the messy, natural language of the human.
And in the case of Chronicle Craft Technologies, they're proving we can do it safely, securely, and completely offline.
It completely reframes our relationship with complex systems, turning the computer from a stubborn tool into more of a collaborative partner.
Definitely.
And, there is a final thought here that builds on the foundation Vortex is laying, which is really interesting to think about.
What's that?
Well, if we are now successfully utilizing local, offline, artificial intelligence to translate human intent into offensive security actions, like launching a vulnerability scan with nothing but our voice.
Right.
How long until we see the emergence of voice-operated defensive
Oh,
networks?
wow. That is a staggering concept to consider.
Just imagine a future where a network operator sees a massive anomaly forming on their dashboard, like an active breach in progress.
Okay.
Instead of scrambling to type out a dozen firewall rules to isolate the threat, they simply speak out loud into the room. Lock it down.
And the system just listens.
And the entire digital infrastructure instantly understands that human intent. It translates those 3 words into 1,000 localized commands, rewriting its own firewalls, closing ports, and shifting security protocols in real time.
That is incredible.
The conversation between human and machine is truly just getting started, and the speed at which we can communicate intent might soon become our absolute strongest defense.
Hopefully, someday soon, we can finally turn on the lights in those dark rooms, stop furiously typing green code, and just start talking to our systems like the assistants they were always meant to be.